Awesome. All right, welcome everyone to our CloudBees Connect virtual CloudBees Core workshop. I'm happy that everyone could make it today, and we're going to do a quick overview before we begin the series of labs on the tools that we're going to be using today. It's going to be CloudBees Core, which is an enterprise-grade version of Jenkins. We're going to be running this on Google's Kubernetes engine. We're also going to be using Zoom and a functionality within Zoom using breakout rooms for specialized content based on your knowledge base with Jenkins, Kubernetes, as well as any experience with CloudBees Solution Suite as well. And then lastly, we're also going to be using GitHub. So for some of us who aren't familiar with GitHub, we're going to have some instructions on that as well. So before we begin, I'd like to do a quick overview of the agenda. What we're going to be going through are the workshop tools, the functionality that you need to know within Zoom to ask questions, to assign yourself to certain breakout rooms, and kind of the overall flow of the workshop material and how that's going to be presented to you by our CloudBees Solutions Architecture team. Before we dive into the actual lab work, we're going to go through exactly what CloudBees Core is, what it does on top of open source Jenkins, and how it provides an enterprise grade version of Jenkins for you to run this at scale with unified governance and standardization. The third section we're going to review is a setup for the labs, and then there's going to be a sequence of labs going over configuration as code for Jenkins, pipeline manageability with templates and governance, the ability to set up cross-team collaboration, so end-to-end from commit through security to delivery across different teams and different masters, how CloudBees Core can address needs like this. And then lastly, a brand new piece of functionality that's currently in preview, but it's really interesting, specific to Kubernetes, and that is the ability to have hibernating masters to free up some compute space within your Kubernetes cluster should that master not be used for a certain amount of time. So that's an overview of where we're going to be actually running today. You can see we have quite a few attendees for the CloudBees Connect event, and that's great. We're so happy that all of you could join us today. In order to accommodate all of these different needs, we're actually running this workshop on Kubernetes, specifically a CloudBees Core cluster setup on Google's Kubernetes engine. This is really, really impactful because during these labs, each one of you is going to have your own Jenkins master. If you're not familiar with the Jenkins terminology, it's a Jenkins server where all of this configuration in your jobs will be set up. And because each one of you gets your own master and we don't exactly know the number of attendees to be expected for events like this, we specifically designed it to run on Kubernetes. This way it can auto scale up to fit the needs no matter how many folks are in attendance. And it also showcases a lot of core functionality that is specific to Kubernetes as well. And from our perspective, if you're able to run CloudBees Core or CI/CD in Kubernetes, it's the most ideal situation as well. All of the instructions for the labs in these slides, they're all publicly available on GitHub. So while we're trying to align the material and the discussion around your pace and your experience level, if you fall behind or if you need to go faster due to time restrictions, you're able to do this as a self-paced lab or workshop as well, all based on those slides in GitHub, and the labs are published there as well. It's very step-by-step. We'll leave the environment up for at least another day. So if you want to come back through and try out a new lab that you didn't get to, or you want to review a lab that you had previously done, please feel free to do that. And lastly, the only other thing that's just going to be required for all of the workshops today, that's going to be a GitHub account. So nothing that you do today is going to be a paid for solution. Everything will be free from your end. All you need to do is bring a GitHub account that you already have, or you can create a free GitHub account as well. And we'll go through that in the first part of the workshop, which is just setting up your core instance, your master, as well as your GitHub account as well. So as we continue, it's important before we actually dive into the labs to do a quick level set on what CloudBees Core is and what kind of functionality it provides as an enterprise grade version of Jenkins. So at the primary tenets of CloudBees Core and what it's really driving is the ability to increase your productivity at scale, so that you're able to incorporate many different teams, many different microservices, eliminate the manual handoffs between these teams, automate your processes from code commit to testing to deployment and approval processes, all within a system that's built on top of open source Jenkins. And if you're not a common open source Jenkins user, Jenkins is an automation tool, and it's really easy to integrate with almost any of your tools within your software delivery lifecycle that you're using today. And this is all done by the Jenkins plugin ecosystem. There's about 1,700 maybe 1,800 at this point, plugins that allow you to integrate with all of the tools that you're currently using within your development teams and your software delivery lifecycle. So we're adopting all of those best things that make Jenkins the leader in CI and CD, and we're just making Jenkins more applicable to, larger enterprise groups. Secondly, we're really trying to eliminate the silos, that concept of shifting left, empowering your teams, as you'll see as my third point as well. The idea of we don't need to build these walls between security and development teams. And then there's release teams or deployment teams as well. We want to eliminate those. We don't want to have that concept of throwing bits over the fence, waiting for feedback. Instead, during these workshops, we're really going to showcase the ability of teams to quickly iterate on new changes, see if there's any errors, go back into their source code, make a new change, automate that new build or testing suite or deployment, all from GitHub in this case, and all that's happening via automation within CloudBees Core on the back end. So it's really, really that idea of eliminating those silos and those manual handoffs and waiting for feedback loops. We want to fail fast and iterate to resolve those errors that occur within CI/CD platforms. So another point around empowering your teams. As I mentioned earlier, we are giving each one of you your own masters today. And this is something that we're all going to be going through the same material during our workshops, but in a production situation, this is really meant to showcase the ability to give individual microservices or software teams their own Jenkins master. This gives them the ability to onboard their own pipelines, which are those automation jobs that I was discussing, as well as their own integrations with their plugins that are needed and their own credentials, so that they are self-contained on their master. They're not reliant on other teams. So you're really adopting that idea of giving freedom to your developers, shifting further and further left. And that is the main driver behind DevOps. And those organizations that can shift the focus to the development side, those are who we're seeing being the most successful when it comes to agile methodologies. And then lastly, one of the most important things that we're going to review today, and why CloudBees Core is a great solution for enterprises over open source Jenkins, and that is the ability to ensure security and compliance at scale across these many different masters. And the way that that's done, as I go to the next slide, is we have many different masters supporting these different teams or microservices, but they're all connected to one centralized Jenkins operations center. And you can think about this as a master of masters, and it's the concept of an overlying command center on which you can set unified governance, set your integrations with LDAP or Active Directory or Okta single sign-on. This way everyone falls within the same authentication realm. You can set shared agents or shared servers on which some of these jobs will occur on, shared libraries for certain functionalities so you can iterate on best practices, as well as credentials to link to certain shared libraries or tools that you need. So this way you're not spinning up open source servers in Jenkins that are just run kind of as siloed individual efforts by each team. Instead, you're able to combine all of these Jenkins masters at scale so they can all fall within the best practices that you as a shared services team, or maybe you're a Jenkins owner or a CI/CD lead, that you set forth. So this is the general concept or architectural layout that you see on this slide that we're really driving and adopting with CloudBees Core. Just as a few extra points that I'll mention here, you'll see in this example, these are supporting different development teams or microservices. For example, the web team and the mobile team in a production environment. They are completely different developer teams. They have different needs, different credentials, different integrations. They don't need to share the same server. That whole idea of project isolation and scaling out architecturally to where they can fit each one of those teams on their own master. That way they have their own solution suite, their own integrations based on that server level. That is a really core component and a big part of what CloudBees Core is focusing on today. So as you're going through this, it's important to try to think about how would this work within my own production environment as well. So if you're not a Kubernetes professional or whiz, this might seem a little foreign to you, but this is the architectural layout of CloudBees Core on Kubernetes. In our example today, it's actually CloudBees Core on Google's Kubernetes engine. You'll notice that each one of those components that I was just discussing, the operation center, that command and control console, that lives as a container within a pod in Kubernetes, and it is connected to many masters. In this case, you see them as managed masters. So each one of those masters, as you look left and right on this slide, that represents the Jenkins server that you are using, and then the second one could be a master that another attendee is using today during these labs as well. And then the last component, and something that I briefly touched on, and if you're not a Jenkins professional today, you'll see container agents as well. When we're doing work within Jenkins, there's this concept of distributed pipeline architecture. And that's the concept of all work occurring on agent nodes. So an agent node might contain a specific version of Java, like JDK8, for example, or a specific tool on it. Let's say like Canico or SonarQube. Those individual steps that are being automated, like a scan within Sonar or a build that's occurring with Maven, those occur on container agents in this case, and those are attached to those masters to run those steps. We don't actually want those steps running on the master. Instead, a master just supports an individual team's configuration, credentials, and interprets the syntax within a pipeline that automates those agents, if that makes sense. So it's the idea that a master controls the larger configuration of a team, but all of the steps that that team needs to run within their pipelines, those occur on agents. And in this case, those agents are containerized Docker images that are then spun up on pods. And a big component of Kubernetes that makes this really great is that those pods that run agents, they can be ephemeral as well as elastic. So as we spin up pods today to run certain items, like we're going to spin up many node pods during our workshops, it's going to scale out using auto scaling groups in GKE so that we can spin up multiple of these across no matter how many masters are present in our workshop environment. And then once they're done, the ephemeral nature within Kubernetes will spin those pods down. So once they've been successful, that will free up some space within our Kubernetes cluster. So at this point, I think we should have a pretty good idea of where Core fits in as an enterprise grade version of Jenkins, and how running things at scale is really adopting those best practices that are set forth by the industry of becoming more agile, being able to fail fast, separating your different teams, segregating the duties and the integrations to only a team or a microservice level. But with that, we're also adopting this idea of managing Jenkins at scale. And that might seem very intimidating because you might currently be managing a single Jenkins master and you think this is too much for me to even think about managing 3 or 4 or even a dozen masters if I had to adopt CloudBees Core. Well, a big part of what Core allows you to do is not just run it at scale, but to effectively manage this at scale as well, to limit the amount of effort that goes into managing multiple open source Jenkins servers if you were to adopt that approach. So the first point that is really something that we're going to showcase within this workshop is the ability to verify and curate lists of plugins. So as you're running this at scale, you want to make sure that everyone is in compliance using certain versions and certain plugins. That's made really easily done by the CloudBees Assurance program, which ensures you're using the most up-to-date and secure versions of a certain set of plugins. That's about 140 plugins today from CloudBees. We actually publish that list of verified and validated plugins to your CloudBees Jenkins Operations Center on a monthly cadence. And in one of the labs today, you'll see a way to expand that CloudBees Assurance program to encompass more plugins, because inevitably you're not just going to use plugins or integrations from the CloudBees Assurance program. You're going to need to expand that to use certain plugins that other teams need as well. So the ability to do that, whitelist, verify plugins, and ensure that compliance at scale across the masters is really, really impactful for running a standard Jenkins operation. Secondly, you'll see an easy way to manage and maintain your Jenkins configuration is to do this with a GitOps mentality. Everything is configuration as code. It'll live within your version control system. So today that's all going to be within GitHub. You can make changes to your config, changes to your plugins, changes to your credentials, all within your source code base, within the Jenkins configuration as code that's proprietary to CloudBees Core. And then you can reapply this to your Jenkins masters. This way, rather than going in and manually tracking edits or trying to build some audit log for the configuration changes that you've done all within a UI, you can do this all within Git. You can adopt GitHub issues. You can adopt GitHub auditability through the tracking of comments and pull requests and merges. It's all really easily done, and you can start doing and maintaining your Jenkins configuration the same way that your developers have been maintaining application code for years. And then lastly, a really nice way to wrap this up and how to manage Jenkins at scale is the ability to map those masters per team, but then centralize the role-based access control across these different teams. So you can set up role-based access, limit what kind of teams have permissions to, let's say, upload plugins, create certain masters, even the job types that they're able to create as well. That can all be done from the operations center level. That way you don't need to do this at an individual server level, or you don't have to be reliant on software leads to do this for you. It's also another great use case for sharing certain sets of configuration, whether they be credentials or agents at a global level. This way you don't need to replicate that storage or that maintenance across many different servers. And lastly, this will be a highlight of one of our labs today around message bus and the ability to do upstream and downstream tasks between masters. You're able to configure the triggering of jobs across different servers and different teams via a message bus that lives on the operations center. And you can do this from external webhooks as well. So that can all be set up at the operations center level. That way you can really maintain this to be an enterprise version. And that way you're not reliant on individual teams to keep up with their own masters. So at this point, we would like to break everyone up into their specific breakout rooms. So at this point, everyone should have taken the poll. You've now added the prefix to your name for which level of knowledge or experience you have with GitHub, Kubernetes, and CloudBees, as well as open source Jenkins. And based on that, we're going to break you all up, and we'll open up the audio channels as well. If you have specific questions, please, these labs are best utilized when it's very interactive. So give us any feedback throughout, any questions, and we'll proceed from there. But thank you all for joining. All right, welcome to our breakout room. Everyone, thank you for taking the poll and for the quick overview. We're going to start the first workshop lab for CloudBees Core. This initial lab is just going to be a CloudBees Core workshop setup. So what we're going to be doing is standing up your first master. So like I mentioned, this is going to be a master that is specific to your individual instance, and it's going to be spun up on Kubernetes as a pod from a container. It's going to be referred to as a team master in this case, and a team master is specific to a Kubernetes installation. The only difference between that and what you'd consider a normal master, a client, or a managed master, a team master is specific to Kubernetes and is actually spun up from Blue Ocean. Blue Ocean is a plugin from CloudBees that in the open source is generally used as a nice, fancier UI. And it's a good way for you to interpret what syntax is being executed within your pipelines. It also provides you a GUI editor for creating pipeline syntax as well. But in this case, it can actually be used in Core to create a master, and we're going to showcase exactly how that works during this workshop lab. The second part of this setup is going to be setting up your GitHub user account. It's going to be used throughout this workshop. Like I mentioned, it's going to be free. If you already have one, you feel free to use that one as well. We're also going to be standing up a personal access token for your user account on GitHub. And that's going to be something that is really necessary so that we can trigger webhooks. So each time a commit or a merge to master is done today, it'll dynamically kick off a job on your Jenkins master. That way we don't have to manually kick off these jobs as we proceed through, and it'll really speed up the process. And using webhooks in your production environment is a highly recommended practice as well, because you don't want to be manually kicking off jobs every time you make a change. And lastly, the last thing that we're going to do within GitHub is we're going to create an organization. And within that organization, it's going to be the home to many different repositories that we're going to use throughout this set of workshops. And as part of the first jobs that we're going to run today, it's actually going to fork a certain set of repositories over to your organization. And on that organization, as I mentioned, we're going to use that personal access token to create a webhook so that any changes done to any one of those repositories that is forked over to your org will trigger that job. So it's going to be an org level webhook that we're using today. And that's a really nice way to manage and maintain multiple repositories from a Jenkins perspective. So now enough discussion, enough talking. It's time to actually get into the material. If you want to click this URL, it's going to take you to our GitHub landing page for our workshop setup, or the first lab that we're going to be going through today. At this point, everyone, you are now within our GitHub workshop pages. So from here, all the material for all of the labs will be accessible to you. It can all be self-paced. Like I mentioned, if you fall a little bit behind today, you can take it from here. We also have some assistance in my breakout room as well. Today I have Greg Abzuk, who's going to be presenting the other labs with me, but he'll also be able to help you in an individual breakout room should you have some sort of a debugging issue that you need to go through, or you need some additional explanation. Please just post it in the chat. You can communicate with Greg via text and via the chat window, or if needed, we can kind of do a further breakout to do individual screen shares and things like that. From here, what we're going to do is you're going to bring up this registration form URL. It's going to be an application that's going to allow you to sign up with a username, with your email, your first and last name, as well as a password that's going to be used for your CloudBees Core login for all of the workshops today. So click to sign up. You should be emailed a password that you can use, and then you're going to navigate to the URL within the chat window that we've just provided now, and you can go into there and you can sign in to using your username and password that was just generated from that previous form. So at this point, I'm going to navigate over to the core login, and I'm going to use my username and password. Sorry. You might want to choose to remain logged in just for a little bit, so in case you're in the instructions, you don't get logged out. And at this point, you have just authenticated into CloudBees Jenkins Operations Center. So that is the master of masters, like I discussed earlier. And you can see from this console, there are many different masters that are connected today. And as everyone signs in and registers, you'll actually be able to see all of the masters across all the different breakout rooms. And this is a really good point to showcase the scalability of CloudBees Core, especially on Kubernetes. So as we go through this, I'm going to show you how to spin up your master, and you'll see it connecting to this CloudBees Jenkins Operations Center. So as we continue down, if you're in the instructions, you should now be down at this point of creating a team master. So within this view, what you're able to do is you can actually go to Blue Ocean and create your team master directly from that Blue Ocean interface. So I'm going to do it all within the UI now, but I'm going to be following along in the instructions. If you just want to look at the instructions on your side, that might be easiest. But just for some context, the first thing that we're going to do is we're going to navigate to Blue Ocean. This is that Blue Ocean plugin. It's the blue and white yin yang, like I mentioned earlier. In open source Jenkins, like I mentioned, it's a really nice way for you to visualize your pipelines, the execution, and you can actually even create declarative pipelines using the GUI editor as well. But in our CloudBees Core installation, we're going to use it to create a team master. Remember, a team master is just the syntax that we're using to define a master created from Blue Ocean on Kubernetes. So while you can think about masters as supporting teams, team master is a particular nomenclature for CloudBees Core using Blue Ocean on Kubernetes. So create a team. Give your team a unique name. I recommend something like your GitHub username, something that can differentiate you from other users. Don't just go with CloudBees Workshop, because we might end up with 40 CloudBees Workshop masters. It's going to be hard for you to determine which one you need to be working on. So in this case, I'm going to name mine tjohns2. You can give yourself an icon and a color for what you want your master to look like. You can assign users to your master for future instances, but for now, you just want it to be your user as an admin. You're not going to be editing the cluster endpoint today. We're also not going to be using a master recipe. Instead, we're going to be using that Jenkins configuration as code, as I mentioned, but the master recipe is just a way for you to install plugins out of the box on this master as soon as you spin it up from Blue Ocean. It's a really cool way to get a production-ready master up and ready for work. But we're actually going to showcase a better way of doing this, and that's using config bundles with CloudBees Core. So create this instance. And one really important button that I want you to see today, if you're not familiar with Jenkins, as this is the Blue Ocean view, if you want to navigate back to the traditional Jenkins UI, which looks very similar to the open source Jenkins, and you might have noticed that when you authenticated in, it's actually designed that way because CloudBees Core is not supposed to be a completely new solution. It's not really a rip and replace of a CI server. Instead, it's an upgrade. It's a way of taking Jenkins and then making it even more functional, more adaptable to your enterprise needs. So it has a lot of the similar look and feel of Jenkins. But to navigate back to that traditional UI, just click this arrow inside the square here. And that's going to be an important button as we navigate in and out of jobs today. So once you're back at the Operations Center view, you should see your master with the red X as it is spinning up currently in a pod on this Kubernetes cluster, and it is attaching itself to this Operations Center. And once that is spun up, we can actually begin creating jobs, setting up an initial workshop job that we've already deployed on this master, which is going to do all of the effort of forking over repositories to your organization, setting up your credentials with your personal access token, all of that greatness. And we'll show you how that works once your master is up. But if you're back in the instructions, and I'm going to navigate back right now, we've gone through the Blue Ocean setup of your master. You should all see this icon. You should be back at the traditional UI. And from here, what we're going to do is create your GitHub account. So if you already have a GitHub account, just log in. If you do not have a GitHub account, go to this GitHub URL/join. And from here, just create a free GitHub account that you can use for today's purposes. If you don't want to maintain and keep it after the fact, just delete it after the workshops. But when you do this, as you're selecting your plan, make sure you choose unlimited public repositories for free. Like I mentioned, don't select any paid for solution from GitHub for today's purposes. So once you have that, you can see here at this point, you should have a GitHub landing page, and this is your profile. And within the instructions, the next step is going to be creating that personal access token for your username in GitHub. So the easiest way to make sure you have all of the correct credentials for that personal access token is just to click this blue link, and it'll pull up where you need to create your personal access token and with what specific credentials or access it's going to need in order to create this personal access token for you. And we've done that out of the box. So you're gonna have all of these selected. You're just gonna give it a name. And then also with that name, you're just gonna generate it as well. So I'll call it CB Workshop. And I can generate that token. And now this token, you're gonna wanna copy this text because you're gonna be using this throughout the workshops today. So copy that, put it in a text editor somewhere safe, because once this has been created and you leave this page, you will not be able to access that string again. And we're gonna be using it throughout the labs today. So make sure you store that somewhere safely, and we will show you how to add that in our first job. So as I copy that over somewhere where I can use it, here we go. I will navigate back to the instructions. So at this point, you should have a master spinning up. If it hadn't spun up yet, you could go back and check. You should have your GitHub account. You have now created your first personal access token. And just for reference, if you're new to GitHub in this group, if you ever need to see the personal access token or create a new one, you can do that all from settings. And from within settings, you can actually go to developer settings and you can click your personal access tokens. And in my case, I have two, but you should see the token that you created. And if you ever need to create one in the future, it can be done directly from this window as well. So next, within GitHub, what you're going to do is create an organization. This organization is going to be the home for all the repositories that we're going to use for today's workshops. And it's also going to be the destination for our webhook that we're going to create today back to your Jenkins master. And it's going to have that webhook stood up on it so that any change to any repos or any source code from within that organization or the repositories inside of that organization will trigger builds or jobs automating on your Jenkins master as well. So go back to your landing page within GitHub, and from the plus arrow here, you're going to create a new organization. don't create a repository, you're going to do an organization. You're going to click the free option. Once you have the free option, it's going to ask for a name. This is going to have to be distinct. So I'm going to give mine the same name as my master if it's available, which it is. It's going to require a contact email. Use the same one that you registered on GitHub with. Just deem that it's for your personal account. Select next. It's going to ask you to invite people to collaborate within this organization with you. You can just skip this step for now. If you ever want to use GitHub in the future and do this, this is just some context on how that's done. And voila, we have a GitHub organization. And you can see right now it is empty, but this job that we're about to run when your master is up is actually going to fork over a series of repositories that we're going to use. It's going to fork them from a CloudBees organization directly to your organization. So if you're not familiar with the concept of forking, it's just kind of copying them over to your organization to where you can work on them with your own domain here. So back to the instructions. You will see at this point we've finished our organization, and now what we can do, if you go back to the CloudBees Core console where you have created your master, from here what you're able to do is you can see that your master should now be online. So I'll refresh my page. Back to your master level, you'll notice that all of the masters fall within that Teams folder. Much like I mentioned before, the Teams folder is just a specific syntax for masters provision from Blue Ocean on Kubernetes core installation. So select your master. From within your master, you're going to have to go another folder level down, and that's just done as a blue steel folder. It's this specific folder that is generated on Team Masters. Not really much that we need to go in depth on that. But from here, you'll see two jobs, and we're doing the core workshop today. So you're going to select the core workshop job. And just so we can visualize this better, you can go to Blue Ocean. Open Blue Ocean, you'll see the core workshop setup job come up. And then from within here, what you're going to do is select run. So if you select run, it's going to drop down a set of parameters. And from within these parameters, you're going to plug in your personal access token that you just generated. If you just created your first GitHub account, you're going to be plugging in your GitHub username, as well as the organization name that you just created as well. And what that's going to be used to do is, one, it's going to set up that credential for the webhook on your master. It's going to use your username and organization name to then fork over those repositories. So it's really important that those are correct. So I'll just paste in my personal access token, my username in GitHub, as well as the organization that I created as well, which is tjohns2. And then you're not going to alter this last parameter. This is just a default that we've set in there, and you're going to kick off the run of this job. So as it's running, you'll see the first execution run come up. And as it goes through, what is going to happen here is it's actually going to restart your master as well. So what you'll see as this is executing, if you select that first run, you can see the different tasks going through. It's waiting to spin up some agents to run this on, but it's actually going to restart your master, so it's going to be unavailable. But in the meantime, what we can do from here is we can actually continue on with the instructions, and we'll go back to the workshop slides after you've kicked this off, and we can do an overview on what we've accomplished during this lab, and we can start an overview of our second lab while our master restarts. So as an overview, what we did during this initial setup lab, we were able to first create a master. We did this on Kubernetes, so it spun up a master for you along with every other attendee of the CloudBees Connect event, and that was all done by the amazing auto-scaling groups within Kubernetes. And our CloudBees Core is installed on Kubernetes so that we can do that, as well as spin up agents, which we'll do in some future labs as well. What we've also done is we've created your GitHub account, your personal access token, our first GitHub organization, and then from within that, we just kicked off a setup job on our master after it spun up to fork over a series of repositories, in this case 5 repos, to your GitHub organization. So what you're going to see inside of your organization now are 5 repos. One that is a core configuration bundle that we're going to overview in the next lab. This is going to be a repository that provides a base set of configuration as code for everyone's masters. From within that base set, we're actually going to make some changes so that you can reapply a configuration bundle and update your master. We also have, second, a shared library. If you've used Jenkins before, you're probably familiar with the concept of shared libraries. It's this concept of reusable code, functions, basically just stages and steps within Jenkins that can be reused from pipeline to pipeline. We have one of those stood up that's already populated with some of those that we're going to use inside of our templates and pipelines as we continue forward. Third, we have a pipeline template catalog. This is something that you're probably not quite as familiar with. It is a proprietary feature within CloudBees Core. It's the ability to create a set of templatized end-to-end Jenkins files that then you can create on the fly that are production ready, verified, validated by the owners of Jenkins or the shared services group, so you can really provide Jenkins pipelines as a service for your developers. We're going to highlight that in a lab as well. And you'll also see two repositories that are a microblog front end, which is a Vue.js sample application, as well as the microblog backend written in Python that's going to be used in conjunction with that front end application. And we're actually going to deploy that today as well to a preview environment. So if you go back to your GitHub organization as your job is running, you will see that once it has found its agents to run on, it'll actually begin forking these over and your master will restart. So for the meantime, I think we can continue to our second series of labs on configuration as code bundles led by my colleague, Greg Abziak.
But so like Tyler mentioned, while our core workshop setup job is still running, right, we're forking over those repositories, our master is going to restart with that new configuration bundle in place. In the meantime, we're going to go ahead and dive into our second or first lab, which is this configuration as code for CloudBees Core lab. So what is CloudBees Core configuration as code? Configuration as code for CloudBees Core simplifies the management of a core cluster by capturing the config of core masters as human readable code in a collection of YAML files. So why do we want to do this, right? Some of you might be familiar with the idea of GitOps, or just, you might be doing other things as code, such as pipelines as code, for example. And we want to do this just to kind of get all the benefits of being able to store our code somewhere, right? We can then version that code, we can test it, we can validate it, and we can take all those processes and we can now apply them to our CloudBees Core masters. And just like Tyler mentioned before, this collection of YAML files that stores our configuration as code is known as a configuration bundle. So what goes into a core configuration bundle, right? Just as we mentioned on the last slide, the config bundle is made up of a collection of YAML files. And these 4 YAML files that you see in front of you, those are the 4 files that make up a CloudBees Core configuration bundle. The first file is the bundle.yaml file. This provides a version for the overall config bundle, which must be incremented with each update, as well as references to the other files in the bundle. The Jenkins.yaml file contains the Jenkins system and plugin configurations. The plugin catalog YAML file provides a list of plugins that are allowed to be installed on your master that are not included in the list of CloudBees Assurance Program core plugins. And then finally, the plugins.yaml file contains a list of all plugins that will be installed / updated on the configured manage master or team master, but only if they're also included in the plugin catalog YAML file mentioned above. And once our setup jobs are done running and we have that config bundle repo forked into our GitHub org, we'll actually take a look at these 4 files really quickly just to see what the config as code actually looks like before we jump into the lab. So, what did we do to enable configuration as code for our core masters, right? The setup job that everyone is currently running or has run actually updated that Jenkins.yaml file inside of your repository with specific GitHub information, right? And so then your team master that you created earlier will be, for some of us, it has already been provisioned. For others, it will, it's still kind of spinning back up, but it's actually spinning back up with that new config bundle in place to take effect. And, there's just a lot of kind of specific information on the last 2 bullets here where you can see kind of the specific changes that were applied as we're spinning up the masters with this new config bundle. And so one of the big things that we want to mention that we did is inside of that Jenkins.yaml file, and again, I'll show off these files in just a minute here, but inside the Jenkins.yaml file that's the file that provides the Jenkins system and plugin configuration information. It's kind of the meat of this configuration as code aspect. And one thing that we did that you'll see in the file when we go over it is when you actually entered your GitHub personal access token at the start of the job, we took that personal access token and we used that as part of the config as code here, right? And you can see a little snippet right here where we took your personal access token, we encrypted it, and we stored it as code. And now once your master restarts, we'll see this in the lab, we can actually start utilizing the personal access token without you having to do anything through the Jenkins UI. And so, it was actually used to create 2 user-specific Jenkins credentials, which we'll see in a second. There's kind of multiple ways to do this. We are following option number 2 here, right, where we can use it, basically encrypt the value that you provided with your personal access token, and then we store it inside that file. And then once your master spins back up, then the Jenkins internal secret key, you're able to access it as you work through the rest of the workshop, the rest of the labs. And then there are a couple other things that we have done in the setup job, including creating the credentials, right? We also configured the core pipeline shared library at the Jenkins global configuration level so that all of the Jenkins pipeline jobs will have access to that shared library, right? Even though we all are on our own separate team masters, we automatically configured our team masters to look to the shared library that you've also forked over into your GitHub organization. And then there are a couple other changes. We applied a system message to each individual team master to show that the configuration as code was applied. And then we installed a couple of plugins that we're going to need throughout some of our workshops later today. And so in just a second here, we're going to jump into the lab. You can see that's the next slide. But before I jump into the lab, I wanted to show off the config bundle repository that we all should have forked over if our job has finished running. And so yeah, let me ask the room, if you refresh your GitHub organization, did you get the 5 forked over repositories?
Yes.
Awesome. Okay. Great. So let's go ahead and click into the core config bundle repository, right? Again, as we mentioned, this repository is going to be the repository that contains the 4 YAML files that make up this config bundle. This is where all the configuration as code changes that we're going to do throughout the lab, this is where they'll live. So the first file that we mentioned, right, the bundle.yaml file, if we click into it, the most important part of this is this version here, right? You can see when we first fork it over, it's set to version 1. As we go through the lab, we're going to have to increment this version, right? If you don't increment the version in here, then the configuration as code changes will not take effect. So it's very important to make sure that we increment this version every time we make a change to the config bundle. And then as we mentioned, right, this file then points to the rest of our config bundle files here, where we point at the plugin file, the configuration as code file, and then the plugin catalog file as well. If we take a step outside and click into the Jenkins.yaml file, again, this is the file that contains the Jenkins system and plugin configurations, right? So this has kind of a lot of our meat when it comes to the configuration behind our core master, right? So you can see we're defining agent protocols. This is the system message that I mentioned earlier. Here we have some of our plugins defined as well, right? At the bottom here are the credentials that I mentioned. So we're actually taking that GitHub personal access token and we're creating 2 credentials with it that you'll see in the CloudBees Core UI in just a second. And then finally, this is where we're defining the pipeline library as well, right? So you can see we're giving the library a name, cb-days, and then when we jump into our pipelines, you'll see us referencing this. And this is, we're defining what repo we're grabbing that pipeline library from. You can see here, right, as our setup job is running, we actually edited this file with my own repo owner, right? This is my GitHub organization. So for all of you inside of your repository, you should see your own GitHub organization in here, and it's pointing it to this specific repository, right? This is your shared pipeline library repository. And then again, just real quick, the last 2 files inside of the config bundle have to do with our plugins, right? So the plugin catalog YAML file, this is where we define plugins that we would want to include that are not a part of the CloudBees Assurance Program core plugins, right? So you can see we have two plugins here, the basic branch build strategies and pipeline utility steps plugins. We specify their versions. So those are two plugins that are not in the CloudBees Assurance Program that we will want included on our team masters. And then finally, the plugins.yaml file. This file actually has a list of the plugins that we want on our master. And so you can see, right, the two plugins mentioned above that are not part of the CloudBees Assurance Program are in here, as well as some other ones. Those are already part of the CloudBees Assurance Program. So now when our team master spins back up, it will spin up with all of these plugins included now. And if there are any questions at any point, please feel free to enter them in the chat. Somebody should help you along, or if you, since we are in the breakout room, if you want to hop on the mic and ask me a question, I can definitely answer some questions here. But so now we're actually going to go ahead and jump into the lab, GitOps for configuration as code. So in this lab, we'll set up a Jenkins pipeline job in our team master that will be triggered whenever a commit is made to the master branch of our core config bundle repo. And this will allow us to update our team master with those config as code changes automatically. So if you want to go ahead, if you've been following along on the slides, if you want to go ahead and click on this link, that should take you to the lab itself. We'll take a quick pause here, just make sure everyone gets to the lab page here, let everyone catch up. And then we'll go ahead and we'll navigate back to our team master. And so while we were running the setup job, we were in the blue ocean view. Now we're going to go ahead and get out of the blue ocean view, right? And you do that by clicking on this top right button up here, this little arrow right next to the logout button. If we click this, this will take us to the classic view. And so from here, we're going to navigate back one level, right, back inside that folder that contains our core and rollout workshop setup jobs. And from here, we're going to go ahead and create a new item, right? As I mentioned, the whole point of this lab is we're going to create a Jenkins pipeline job that will pick up any changes made to our config bundle repository automatically, right? So we're going to go ahead and click on new item. And from here, you're going to navigate down to GitHub organization, right? This is the job that we're going to create. So we're going to call this, our item name is going to be the same name as our GitHub organization that you made in GitHub, right? So my GitHub org is this right here. I'm just going to take this, I'm going to copy paste it out. I'm going to make that the name of my GitHub organization job. And this is important because, as you'll see in a second, we actually auto-complete some fields for you. So we want to make sure that we name this job the same as our GitHub org that we created for this workshop. And again, you want to make sure you have GitHub organization selected as the kind of job that you're creating. I'm going to click on OK, and this will actually take us to the configuration of this GitHub org. Okay, and so now on this screen, we're going to go ahead and go through the configuration behind this job, right? So the first thing that we're going to do from this credentials dropdown is we're going to pick the credential that has your GitHub username along with your GitHub personal access token. And so just like I mentioned, we'll show this off in a second once we get the job running, but this was auto-generated for you using configuration as code, right? We took the personal access token and we took your GitHub username that you provided when you first ran the setup job, and now you actually have this Jenkins credentials available to you to use in this job. The next thing here is this owner box. So this is what is auto-populated for you, right? This has to match the name of our GitHub organization, right? So that's why we named this job after our GitHub organization, because it auto-fills this for you. If you didn't name it the same thing, then you want to make sure that this owner box has the name of your GitHub organization in there. And now what we're going to do is we're actually going to go ahead and add a behavior to this GitHub org, right? We're going to go ahead and click on add, and you want to make sure that you're under this within repository section. And in this within repository section, you're going to click on filter by name with wildcards. And what this allows us to do is it allows us to specify based on branch name, usually, right, which branches we want to build. So the whole idea behind a GitHub organization job is it would go through the GitHub organization that we created here, right? And it would go through repository by repository. Then if you specify branch, then go through branch by branch, looking for a, as you see here, right, looking for a file called Jenkins file within that branch. And so what we're doing here is we're saying only do that for the master branch in our repositories, right? So we're going to go ahead and add this. So it only looks at the master branch. Make sure you've got that there. And then we're going to scroll down to build strategies, right? And then under the build strategies, again, we're going to click on the add button and we're going to pick skip initial build on first branch indexing. This is a minor thing, but basically, normally when a GitHub organization goes through and it scans, or a GitHub organization job goes through your GitHub org and scans all those repositories, if it finds a Jenkins file, it will actually start a job for that branch, for that repository. What this allows us to do is we're just going to skip the initial branch. All we want to do is we want to scan our GitHub org. We don't actually want to run the pipeline itself. And so once you've done this, you're going to go ahead and click on save, and this will generate our job for us. And so you can see right now our job is actually going through and it's scanning the GitHub organization that we have created. And so we're going to let that scan. But if I click out, you should see that we've picked up one repository, right? We picked up the core config bundle repository. And if I click into it, right, the reason for that is because there's a Jenkins file on the master branch of this repository, which is the behavior that we set in the configuration of that job. And so now we're going to go ahead and click into the core config bundle job here. And so we're not going to run it just yet, right? The reason we're clicking into it is you can actually navigate to the GitHub page from this UI here, right? So if you click on this GitHub button, if I go ahead and open this, even though I already had it open, right, this will take us to that repo, to that specific branch, right? And so you should see as part of the setup job, when you forked over the core config bundle repository, we actually forked it over with a pull request ready. And so what we're going to do is we're actually going to go ahead and go through that pull request. We're going to merge it in just a second here. And once we merge that pull request in, we will kick off this pipeline that we created thanks to the webhooks that we have in place. And then the changes that we've applied to our config bundle code will actually apply to our team master there. So if you want to go ahead and click into pull requests here, right, you can see the pull request that we have open, and we're going to go ahead and click into it here. And so what we're going to do, I'm going to open up the files changed in a new tab. We're actually going to walk through the changes, but just, I know this is a little backwards. We're actually going to go ahead and just merge this pull request right now. Let it start running because there are some things that need to apply to our team master. It takes a little bit of time. So I'm going to go ahead and confirm the merge. I'm going to do the pull request. And then as it's running, I'm going to walk you through what changes were done to our core config bundle. So go ahead and make sure that you've merged, or that you've approved the pull request, you've merged the pull request, get that into your master branch. If we go back here and refresh the page, we should see our little ball is now bouncing, right? That means the pull request went through. We automatically kicked off this core config bundle job. If for whatever reason your job did not get kicked off with the pull request, please make sure to throw something in the chat. Somebody will be along to help you out, make sure that all your webhooks are in place and things like that. But while that's running and while these changes are being applied to our master, I want to go through and kind of talk what changes we applied as part of this lab, right? So as you remember, as I mentioned, inside the bundle.yaml file, this really important step is incrementing the version number, right? So as you'll see in a second, we added a couple of different changes. In order for them to actually take effect, we're going to have to increment the version number here, right? So we updated this from 1 to 2. Then if we look at our jenkins.yaml file, you can see we've added a Kubernetes pod template configuration. This was already updated for us as part of the setup job. And then we also added a hibernation configuration. So this is actually the last lab today. But with this config as code change, we're enabling master hibernation, which you can see here after 1800 minutes of nothing happening on our master, then the master will hibernate, right? It will go to sleep. So that, again, can be included as part of your configuration as code. And then, as part of the setup job, we updated the credentials. And then inside the plugin catalog YAML and inside the plugins YAML, we also added another plugin in here that we want included on our team masters, which is the CloudBees Pipeline Policies plugin. So you can see the CloudBees Pipeline Policies plugin is currently in preview, so it's not on the list of CloudBees Assurance plugins. So we have to include it inside of this file for it to be allowed to be installed on our master. And then we also included the master hibernation plugin and the pipeline policies plugin in the plugins.yaml file itself, right? So you'll see once these changes take effect, that we'll have 2 new plugins on our team master will be configured to hibernate. we'll be able to look at our credentials. And then we should also have, I didn't show this, right? We'll have a new system message on our master saying basically, hey, now you're on V2, which lets us know that this configuration took place. So let's go ahead and navigate back to our master here. And if I refresh the page, and as you see in the lab, right, if you're following along in the lab so far, you should see our monitors here increased from 1 to 2, right? So basically this says that a new version of the configuration bundle is now available. So we're going to go ahead and click on reload configuration, right? We've applied the new configuration, or we want to apply the new configuration bundle. So if we click on reload configuration, this will apply that new configuration bundle for us. So go ahead and click on yes. And now your master should reload with this new configuration bundle in place. And so we're going to let that run. It'll take just a little bit. Any questions from anyone in the room so far? I haven't really looked at the chat, but it looks like there's some good comments and feedback and everything like that. But so once this reloads, we should see those things that I mentioned applied now, right? So if I go ahead and click on my master here, on my team master, you can see, there we go. We went from V1 to V2. We have our pipeline policies plugin now available to us. If I were to go into the credentials, you could see, right, these are the 2 credentials that we've defined in our Jenkins.yaml file. Those are available to us. And then as we'll see in the last lab of the day, the hibernation master lab, you'll see that we've enabled hibernation on all of our masters now. And so that is it for this lab. Let me go ahead and scroll down and bring us back to the slides. So what did we accomplish in this lab, right? In this lab, we created a job that will update our individual team master configuration bundle whenever a change is committed to the master branch of that configuration bundle repository. And then via pull request, we actually applied those changes to our team master. And those changes included new plugins, new configurations, credentials, things like that, right? So just really showing you how much you can control via code, basically, right? And how you can apply those changes to your individual masters.
All right. Well, at this point, thanks to Greg's help on that configuration as code lab, we have now accomplished a few things so far throughout this workshop. We have spun up a team master on our core installation using Kubernetes auto scaling. You've created your first GitHub organization. You've used your personal access token. You ran a setup job to fork over a series of 5 repos to your organization. And you've created an organization level job inside of Jenkins using that personal access token so that any changes that are done within those repos are then reflected automatically as builds on your Jenkins master. Along with that, you've also directly edited, or you've merged the pull request that we already created for you in your configuration bundle to add certain plugins to your CloudBees assurance program and its scope to make sure that you are using standard validated plugins. And you've executed the job on that to update the configuration on your master. And we did that with what we could call a hot reload, the ability to upload that new configuration directly to your Jenkins master without having to restart. So at this point, we've done a lot of Jenkins configuration. We've done a lot of background work within GitHub. It's time that we actually do some Jenkins pipeline work. And the easiest way that we're going to do that, and a really good part that we're going to showcase, my screen just dropped, sorry about that. One really big part that we're going to showcase today is using templates to start our actual pipeline work. And the way that that's going to be done is we had, as one of those repos that was forked over, a pipeline template catalog, and you'll see that those are end-to-end Jenkins jobs that are templatized out with parameters so that you can use them or provide them to developers out of the box. So just as an overview, what is a pipeline template catalog? It's something that provides you a way to version control parameterized templates for certain types of jobs. It's a good use case. It could be standalone pipeline jobs, multi-branch jobs. A really good way to use these is to find general best practices that certain teams are using, find a standardized way to kind of aggregate those into one template, and now you have this validated version controlled example of a pipeline that can be reused across team and team and team rather than having individual snowflake kinds of jobs that are maintained by each team. Instead, what you have is this kind of golden record or golden catalog of jobs that can just be provisioned for each of the teams as they want to be onboarded and execute their automation steps within their pipelines. They don't need to learn Jenkins themselves or maintain these as, once again, Snowflake kind of pipelines on their end. Instead, you can provide them for these development groups, and if they need to be changed, they're all changed within this template catalog, and those are reflected across all the implementations of that template catalog. That way you're not having to change each pipeline when you want to swap out tools or certain steps because you found a new best practice or you've onboarded a new testing suite, for an example. So when you combine these pipeline template catalogs with pipeline shared libraries, that was another repository that we forked over during that initial setup job. It's really optimizing that concept of shared code. So we don't want to completely replace shared libraries. I'm sure many of you have built out complex shared libraries within your open source installations. Template catalogs are not meant to come in and completely replace that level of effort that you've already done. Instead, you can incorporate those in with your template catalogs, much like we're going to do in this lab. And it really allows you to promote that collaboration between teams so you can contribute to shared libraries that can be utilized within your template catalogs. And then at the same time, a big part of what templates provide you is the ability to save time, because there is this pipeline that is production ready to hit the ground for any newly onboarded team. And it's a reduction of errors, because this template that they're reusing and using, every time it's being used, it's still coming off of that golden example that you have in your catalog. It's not a brand new pipeline every time a team needs to be onboarded. So you know that it's been tested. You know that it's a valid pipeline syntax. You know that you're adopting best practices. You don't have to worry about introducing new errors when new teams are onboarded. So in this lab, the first thing that we're going to do is we're actually going to import that pipeline template catalog to your master. A pipeline template catalog is defined as YAML. So within your repository, you'll see inside of the pipeline template catalog, there's many different subfolders. Within that, it has a definition of the catalog as YAML. You'll also see 4 Jenkins templates in there, and each one of those is a YAML file associated with each template with parameters and such. And we'll kind of do a deep dive into what this looks like. But we're actually going to import that catalog to our master. And as you'll notice on your master level, if I click to that really quickly, you'll see that that plugin has been uploaded to your master right here. And that is a proprietary CloudBees Core plugin. So as we continue, we can go right back to our GitHub page where we have all of our instructions. And just like I mentioned, if you look on your master, you will see this plugin that was uploaded, the Pipeline Template Catalog plugin. And what we're going to do with this plugin is we are actually going to import our pipeline template catalogs. But before I do that, what I'd like to do is give you a quick overview of what that pipeline template catalog looks like and the general structure of these catalogs if you in the future find yourself with a CloudBees Core installation and you want to stand up a pipeline template catalog for the first time. So if you go to your organization level and you can click into your pipeline template catalog repository, within this repository, you will see the catalog YAML. This is that version and name of the catalog that we're going to import, all stored as YAML. So it's just the workshop catalog version 1. From within this, you can go back and you can go into the templates. Now you'll see 4 subfolders or subdirectories within this repository. Each one of them in this case is aligning to a specific programming language. That's a really good general rule for when you're creating templates, because generally if you have a Node project, a Vue project, a Java project, they're going to follow a similar path. A Java project might go through a Maven compilation step, some scanning, some testing with JUnit, all of that, a creation of an artifact. That might be a general best practice that you want all of your Java projects to follow along. You might have the same general practices for Vue or Node.js. You want to generate those as templates. That way you don't have teams reaching out, trying to comb the internet to create their own pipelines using possibly unvalidated plugins, unvalidated steps, not even writing them in pipeline syntax, maybe creating freestyle jobs. These are the things that we want to avoid within Jenkins. And it's a big part of building an enterprise Jenkins platform, that ability to create standardization as you scale out, which we've already seen in our previous labs, right? We've scaled this thing out to over 100 masters at this point. It's important that in a production environment, if we have 100 masters, that we're all using the tool in a way that you as a Jenkins owner or you as a shared services group have deemed to be the appropriate use case and the best practice moving forward. So specifically, I'm going to dive into the Vue.js app pipeline. This is what we're going to be using for actual pipeline execution on our microblog front-end application. From within this template, you did notice that I should mention that a catalog can house as many templates as you'd like. Just because we have 4, that is not a limitation by any stretch of the imagination. You could also create multiple pipeline template catalogs and import different catalogs to different masters if you would choose that route as well. But for this case, you'll see our template in here has its own Jenkins file. This is importing a shared library. Like I mentioned, it's an extension of shared libraries. It's not a replacement of that. This is a templatized end-to-end Jenkins file with parameters in it that has, in a production use case, been tested and validated and ready for use. So this can be rolled out to any of our development teams whenever they need it. And then you'll also see with this Jenkins file, this is the pipeline that's going to execute. Those parameters are defined in this YAML. So this is the exact definition of this template. The parameters are stored here. So we have a repo owner, repository, GitHub credential IDs, a GCP project, and a deployment domain. And we can also assign these parameters to have default values as well. So when we actually spin this job up in our UI, for our master, what we're going to do is not change all of them. We actually have some default values already in place. You can also see that I've defined the template type up here, as well as down here, you can see that it is a GitHub multi-branch pipeline template. And from this, we need to import a certain set of parameters in order for us to access the repository that we're going to use within this pipeline template. So in our case, it's that microblog front-end repo. So we're going to need the GitHub credentials, we're going to need the repository owner, and then finally the actual repository name. And you'll see that a good example of a default value for your parameters is that microblog front end. So this is something that we're not going to replace, but you're going to see this again when we create our job. So the last bit that I want to mention, and this is something that Greg mentioned earlier when he was talking about Jenkins files being the marker for Jenkins. When it finds that syntax within a repository, Jenkins knows that, oh, that's a Jenkins file. That's a pipeline that needs to be executed on this master or on the agents that are defined within that pipeline. In this case, we're actually overriding that syntax. So we don't care about the term Jenkins file at all. At this point, we are actually looking for a .vue.js syntax. So if you have a Jenkins file in this repository, it doesn't matter. You need this specific marker match. If you have a .vue.js file, instead of using any Jenkins file that might be within the microblog front-end repo, instead it's always going to use this Jenkins file, the one that is in that catalog specific for this template. So I know that might be a little bit of a confusing concept, but we're just overriding what was the original default marker value within Jenkins, and that is Jenkins file. And now we're saying we don't care about that. We're looking for a .vue.js file. And when that is found within a repo, it's going to provision this Jenkins file, this pipeline on that master. So this is a really good way to expand the use case of templatized jobs and provide it more as Jenkins as a service for those developers, because they never need to know any Jenkins syntax at all. They're just reusing the syntax that you've created and provisioned within this catalog. So for that, as a kind of background on how a template is laid out, we can go back to our instructions. And at this point, what we're going to do is that entire catalog that I just went through, we are going to import this to our master so that we can actually use it, because that catalog needs to be imported to the master in order for certain developers to provision these sort of jobs. So back at your master level, we're at the top level folder. You'll see the pipeline template catalogs plugin. You can select this and it'll ask you to add a catalog. So at this point, select add catalog. Well, we're looking for the master branch of this catalog. And what you're going to say is that where is this catalog living at this current time? Select GitHub. You're going to use the same credentials that you were using earlier, the ones that were created in that initial setup job. So in my case, my Johns2TE GitHub personal access token. Select those, and then we also need to point this plugin to the actual location in GitHub for that template catalog. The easiest way to do this is if you just go back to your organization, Go back to the pipeline template catalog. So you can see I'm in TJOHN's 2 organization, pipeline template catalog repository. Click the clone or download button, and it'll actually pull up a little clipboard for you so you can copy the destination. So just copy that to your notepad, to your clipboard, and then paste that URL right here. Once this has been pasted, it's important that you want to validate this GitHub URL along with your personal access token. Make sure this is okay. So I've gotten the check mark. My credentials and location are valid, and now I can save this configuration. So save this, and once this saves, it's going to begin importing that pipeline template catalog. So you're going to see it scanning through the branch, the master branch on my catalog, and it's actually going to make it available, all of those 4 templates that you just saw in your source code repository. So my scan is complete. I can go back to the pipeline template catalog here, and these are the 4 templates that I now have available for use on this master via the pipeline template catalog plugin and the import that I just did from that forked repository in my organization. So now what we're going to do, I'm going to go back to the instructions at this point. So at this level, everyone should see that you have 4 pipeline templates available, all from that catalog that we just imported using your personal access token and the URL to that repository that was forked over. And what we're going to do from here, and this is a part of the governance that you're able to create within CloudBees Core, is we're actually going to limit what kinds of jobs a developer is able to create based on folder level permissions. So after I've created all of these great templates and I really want to guide my users to actually use these templates rather than creating their own Jenkins files, not everyone's just going to adopt those templates out of the box. Sometimes you're going to have to create some sort of permission restrictions around the types of jobs that they're able to create, because they might say, I don't want to use shared services Vue.js template. I want to create a simple freestyle job for me to just execute really quickly and iterate fast. That's not what we want to adopt. We want to make sure that everyone is using these templates as much as possible. And a good way to ensure that compliance is to create a folder with restrictions or job limitations at that folder level. That's exactly what we're going to do here. And you're able to do that with Folders Plus. It's not something that we're going to dive into with any depth really, but Folders Plus allows you to create these restrictions at a folder level. And in this case, it's going to be restrictions around what types of jobs you're able to create. So if you're following along in the instructions, I'm going to dive back into my master. So at this master level, you're going to go back down to your Blue Steel folder. And from here, we're going to create a new folder. So you'll just go to New Item. And the first thing I want to showcase here, when you see New Item, I click New Item here. I can create anything I like at this master level. I can create freestyle jobs. I can create pipelines. I can create org level folders or org level jobs. I can create any of those jobs from my templates as well. This is what we're trying to restrict. I don't want users to come in and create new GitHub organization level jobs. I don't want them to come in and create freestyle jobs. That is the goal here, is to limit any use cases where that might happen. So what we're going to do is we're going to create a folder, and from here, just call it template jobs. Create this folder. And then within this folder, as you scroll to the bottom, you'll see this little checkbox that gives you the ability to restrict the kind of children in this folder. Select that. And now you'll see all of those new items that I just mentioned, they come up as options. So from here, I'm saying in this folder, when I use my role-based access control and give developers only access to this folder, within this folder, they can only create Vue.js templatized jobs. So from here, they can only create a job based on this template. As I jump back into my template catalog, they're only going to be able to create jobs based on this templatized pipeline that I showcased earlier that we imported from our catalog to our master. So back to the Jenkins console, we will save this, and now we have our folder set up with folder level restrictions on what kinds of jobs are able to be created here. And you'll see, rather than the new item drop down, I only have new Vue.js. So I'll pause quickly just to see if anyone has any questions. At this point, what you've done, We've done a quick overview of the folder structure within a pipeline template catalog. What is that relationship, specifically highlighting how we're replacing that default marker file, Jenkins file, with .vue.js. So we're using a custom marker definition for our jobs. We've also created and imported that plugin catalog to our master, and then created a folder with specific restrictions limiting the job types to a certain template that we just imported. In our case, the Vue.js template. So if you're back in the instructions, just so I can level set and make sure we're all on the same page, you just finished setting those restrictions here. And what we're going to do is from the UI, we're going to use that template to create a job. So if you go back to your master, you can follow along with me here. We're going to create a Vue.js job. This is coming from the template. Create this using something unique like your GitHub username. So mine is johns2te-frontend at the end of it. Select Vue.js, select OK. And now what you're going to see, much like I mentioned earlier, is a list of parameters. These are those parameters that I showed you, if I go back to this catalog, that were associated with this template. So these are the same parameters that we just saw within our YAML file as well. So some of them have default values, and some of them we're going to need to add in, like our credentials and our organization name, so that it can point to the correct front-end repository, front-end application repository that was forked over. So these are those same parameters. In the repository owner space, what you're going to do is type in the GitHub organization name that you created for the workshop. So in my case, that is tjohns2. You're not going to change the repository. This was hard coded in because all this is looking for is your microblog front end repo that was forked over earlier. But you are going to change, if it's not already on your personal access token, you're going to change it to your personal access token. And then you're going to leave the GCP project and the deployment domain. So you just need to make sure that this is pointing to microblog front end, shouldn't require any edits. Make sure this is the name of your GitHub organization, and make sure you have your personal access token as a credential in the dropdown. Save that. And what it's doing now is it is scanning that front end repository, and I can navigate to that right now inside of your organization. It's scanning right here, looking for that .vue.js file. And if it finds a .vue.js file, so here on the master branch, you'll notice there is no .vue.js file. It's not going to detect the job, so you will not see a master branch when that scan finishes in Jenkins. But if it does find a .vue.js, it's going to spin up a Jenkins file or a pipeline based on that template that we imported earlier. So at this point, it is scanning. It found no branches, but what it did find was a pull request. So within this pull request, it's actually running. And what you can do is if you scroll down in the instructions, you'll see that that pull request is executing, just like you see on my screen right here. And from here, what you're able to do is I can actually click the GitHub button here. So I'm going to open this in a new tab. And this is taking me directly to my microblog front end using the CloudBees GitHub reporting plugin. And I can click that pull request, and I can look inside of this pull request. So it's the add marker file. And inside of this add marker file, we can see that it ran a series of checks against that pull request when I scanned in that repo, and my job actually failed. So on here, what you can now do with this GitHub reporting plugin, I should showcase that this GitHub reporting plugin, this is also another preview plugin. It's something that we wanted to show off today. It's a really easy way to navigate from GitHub to Jenkins, back to GitHub, taking you to the exact places in the source code within GitHub and the exact places where those errors occur within your Jenkins logs as well. So when I click the details here for my first error, it's going to take me back to Jenkins, and it's going to take me directly to the logs where I have an error. So I can see right here, I have an error, and it's just a simple typo, function and function right here. So this is the problem that I'm trying to resolve. And it's just a quick typo that needs to be corrected. And from here, what I can do, I'm just going to click the back arrow for simplicity. I can actually go into my files changed. I've found where the error is in my test suite within Jenkins and why this failed in the PR build. Click the files change, and you can see right here this is my typo error. This is what I need to correct. And within GitHub, if you're not an experienced GitHub user, click the 3 dots and you can directly edit this file from this file changed tab. So let's click that. Now it's going to open up an editor. From within this editor, what we're going to do is we're just going to correct this typo, add a T after my C in function. And then what I can do is it's going to go back down to the marker file branch and I can commit this change. Once I commit this, it's going to kick off that PR job again, and this time it should prove to be successful. So I'll commit this change. As this is committing, once that's done, what I'm going to do is I'm going to go back to the Conversations tab, and you'll see that it's going to be running those tests for me. So here are my tests coming up right here, my checks running in Jenkins. This corresponds with the run that's executing right now. I can refresh this. That is running right now, build number 2 on my PR. So it just ran, and I can go back to GitHub. And those 2 checks that were previously failing, they're now successful. I could even open this up in a new tab. It'll take me to those logs for that successful build. So this is that GitHub reporting plugin, so I can quickly navigate between GitHub and Jenkins. So now that I know that this is successful, my PR is ready to be merged. What I can do at this point is I can merge this to my master branch. And once I merge this to my master branch, it will actually show a kickoff within your Jenkins master, a new job at that master level branch, because now we have merged that Vue.js file in. So merge this. And while this runs, I can go back to my view here, click front end, refresh, and you can now see it has detected a job on my master branch and it is now running. So while this runs, we'll do a quick overview as to what we accomplished in this sequence of labs. So at this point, what you've done, you've detected the PR, you ran that initial job on the PR, it failed, you were quickly able to identify that error in GitHub, make those changes directly in GitHub, re-execute, check the log status within Jenkins, and then you could merge that PR so that now it's detecting a master branch. So what did we really do here? We imported that template catalog. You were able to provision your first actual Jenkins job based on the parameters that were used. You imported your own when you created that job at the UI level. You used CloudBees Folder Plus to create a folder and set some restrictions on what types of jobs are able to be provisioned within that folder to make sure that folks are using the specific blessed version of a Jenkins pipeline that you or your leadership, shared services, or Jenkins owners have already created and validated for end users. You've also leveraged the GitHub reporting plugin from CloudBees to find and fix errors really quickly within both the Jenkins output logs and trace that back to GitHub locations. A few things that I want to mention before we wrap up this lab is that the GitHub reporting plugin, like I mentioned, is preview, and the open source GitHub branch source plugin only displays build level statuses, whereas the CloudBees reporting plugin provides a much more detailed Jenkins pipeline event along with the corresponding GitHub statuses. That way you actually have readable and intelligible feedback that you can kind of navigate back and forth between, so you can make those edits rather than just relaying statuses back to GitHub. It's important that you can track those down to exact errors on both ends of your source code management as well as your CI server as well. As the build runs, it will show this real time in GitHub via that plugin. So it's no delay. It's nothing that you need to worry about from that end. But the idea behind templatization and using the GitHub reporting plugin is to keep developers within GitHub as much as possible, somewhere where they're comfortable, somewhere where they know how to operate, rather than having to iterate through Jenkins logs or learn Jenkins syntax. Instead, they can just live and operate all within the GitHub environment. So at this point, I'm going to hand this over to my colleague. I forgot about the Slack plugin. Sorry, Kurt, this is a new slide. Another option that you have similar to the GitHub reporting plugin is the CloudBees Slack plugin. So rather than giving feedback directly to your GitHub account, or within like pull requests, you could actually output this to a specific Slack server or Slack channel. And from there, you can navigate directly into your Jenkins logs as well, much like we showcased in the GitHub plugin today. So the Slack messages are sent directly to the individual users who committed the job or the code that triggered the job, or they can be set to specific channels for a development team as well. So it's a really easy way to get rapid feedback based on build status and possible errors that need to be resolved. So at this point, I'm going to hand it over to my colleague, Greg Avziuk, to take us through our next lab on CloudBees pipeline policies.
And so I know we are coming up on time. The nice thing is this lab is kind of quick. So we should be able to get through it before we run out. And just kind of one thing to mention, right? We've been going at our own pace. Some of the other breakout rooms might have been going at their own pace. As you can see on the agenda slide, right, there are still a couple labs left. As Tyler mentioned at the very beginning, this cluster is going to stay up through Friday, right, for a couple more days. And so if you'd like to, or maybe you've been catching up, came in late or something like that, maybe you're not at the pipeline policies lab just yet, right? So we're going to leave the cluster up. You're going to be able to come back and work on it. And I just wanted to highlight one thing real quick is we mentioned, right, in the last lab is the hibernating masters, right? So all of our masters right now are set to hibernate. And so if you do come back later, you might notice that your master is hibernating. I just wanted to show you what that looks like. So you can see right now, right, one of my masters is hibernated. And so just so if you come back, you're not freaked out or anything like that. When you click into it, a hibernated master, this is what you'll see, right? You'll see, please wait while Jenkins is getting ready to work, and that your browser will reload, right? So all that's happening right now, since we are in GKE, is we're spinning the pod back up, right? Your master will be back up in a couple minutes. So don't be intimidated by this. If you do come back later to work through the rest of the labs, just wait a couple of minutes, your master will be back up, and then you should be able to walk through whatever you have left to work on. So I'm going to go ahead and exit out of this and go and start talking about CloudBees pipeline policies. So pipeline policies for CloudBees Core allow organizations to enforce standards across pipeline jobs, right? That's the main idea. In our configuration as Code Lab, this was actually one of the plugins that we installed on all of our masters. And so we're actually going to go through and see what that looks like, right? So as you can see, pipeline policies are centrally managed runtime validations, and they support both scripted and declarative pipelines, right? So it's a way for either you as an organization or Jenkins admins to basically set standards across, global standards across all your pipelines that will be checked before the pipeline runs or as the pipeline starts running, to make sure that whatever validations you have in place are actually there in the pipelines before running through the jobs. And so you can use pipeline policies to either provide warnings or to fully block the execution of a pipeline that does not comply with certain requirements or best practices. And so there are currently 4 supported policy rules, as you can see here, right? So the agent timeout rule validates that a timeout period was set for tasks executed on agents. The paused action timeout rule will validate that pipeline steps that require an external condition must be defined within a timeout. The paused action in agent rule validates that a paused action step isn't executed on an agent. And then the last one, the one that we will focus on in this lab, the entire pipeline timeout rule validates that a timeout period was set for the entire pipeline execution, right? So these are all things that you can add into your Jenkins files, into your pipelines today. And what the pipeline policy does is make sure that any pipeline, any job that runs on your master actually has those things in place, right? So for example, the entire pipeline timeout rule, we'll see in a second here, you can at the start of your pipeline say this pipeline will time out in 30 minutes, right? Which means if it takes longer than 30 minutes for this pipeline to run, it will stop, right? And if that isn't in place, then we would fail the pipeline policy. And so that's what we're going to go over in this lab, right? We're going to create an entire pipeline timeout rule policy on all of our masters, making sure that all pipeline jobs on our master are configured with a 30-minute global timeout. So let's go ahead and click into the instructions here. So first thing that we're going to do, right off the bat, is we're going to go ahead and jump back into our team master. We're going to navigate to the highest level of our team master. the same place where we set or we imported our pipeline template catalog, that is also where we will define our pipeline policies, because again, these will apply across all jobs or all pipelines on this master. So we're going to go ahead and click into pipeline policies at the bottom left here. And then once you're there, you're going to go ahead and click on new policy, right? So now we're going to add a new policy to our master. And so you're going to fill out all of this, right? And so those instructions are there for you, right? So for the name, we're going to add in timeout policy. For the action, we're going to keep it at failed, but as I mentioned earlier, right, you can either have the pipeline policy provide a warning. So when the job runs, if you don't meet the policy, it will just let you know, it will give you a warning, hey, you don't meet the policy, or you can actually have the job fail. And so we're going to put it on fail. And then we're going to go ahead and click on add rule. And again, these are the 4 policy options that are available to you today, right? So we're going to pick pipeline timeout. That is that entire pipeline timeout rule. And then in here, we're going to add 30 minutes, make sure minutes is in all caps. And that is the rule, right? That is all we need to do. What we're saying, and you'll see in a second here when we look inside of our template itself, right, is if there is no 30-minute timeout set for this pipeline, then that pipeline will fail, right? That's what this policy is saying. So we're going to go ahead and click save. And so now if I can go back just to check on it, right, it's there, that policy is there. And so now that policy will apply to all of our jobs, right? So if we navigate inside of our Blue Steel folder, inside of template jobs, back to our, that job, right, the pipeline template catalog job that we created, into the master branch, right? Now we can go ahead and kick off that job again manually just to see if the policy that we set does the job that we created in the last lab, does it pass the policy that we set or not. So I'm going to go ahead and hit build now. And then if we jump into the logs, right off the bat, right, you see that the job failed, and you can see right here, right, that the following policy is enabled. So we're basically saying that the policy for max timeout in 30 minutes is enabled. And then right after that, we get an error saying that, hey, you did not pass this policy, right? A maximum timeout of 30 minutes must be set for our pipeline. And so if I close that on my GitHub here, if I go back into the pipeline template catalog, right? So let me just navigate back here, right? If we look inside of the Jenkins file, you can see we have our timeout commented out right now, right? So when this job is running, there is no timeout set for the pipeline. And that's why we end up failing that policy check, right? The policy check expects there to be a maximum timeout of 30 minutes set for the pipeline. We have that commented out, so it's not actually there right now. And so we fail right off the bat. So what we're going to do is we're actually going to go ahead and introduce that policy. We're going to introduce this little rule to our pipeline itself, right? Which says, hey, if this pipeline is running for longer than 30 minutes, stop, right? We're going to introduce that rule, and then we should see ourselves passing that policy, right? So I'm going to go ahead and click on this little pencil right here, right? This allows us to edit the file inside of the GitHub editor right off the bat. And you're on the master branch, that's fine. So we're going to go ahead and click on the pencil. We're going to take this timeout rule that's already in place for us, and what we're going to do is we're going to delete this commented out part. Right. And so as soon as we delete that, now our pipeline, right, the entire pipeline, remember that rule is for the entire pipeline. It's not stage specific. It's not agent specific. It's for the entire pipeline. Now we have a timeout set in place for our entire pipeline in here. Right. And so I'm going to add a commit message, add timeout for pipeline policy. And we're going to commit it directly to the master branch, right? Because we want to just kick off that master job right off the bat. So once you hit commit, the changes there on your master branch. Right now, our master branch has that timeout rule in place. If I navigate back to my core job here and wait a second here, it should kick off automatically, I believe. Oh, nope. That is silly me, right? That's actually in the lab. I'm skipping instructions here. So first, right, because we actually did this on our template catalog, right? I didn't make the change in my repository, right? This was in the front end repository. So I need to go back into my master, click on pipeline template catalogs, and I want to make sure that the change that I made was actually re-imported. And that's what the instructions are saying there, right? So I'm going to go ahead and click on this, and I'm just going to click on run catalog import now, just to make sure that we picked up those changes that we made to our pipeline template catalog. And then once we did, right, once those changes have been applied, then we can go back to that job on the master branch, kick it off, click build now. And again, so the reason it didn't happen automatically is because I made changes to the template catalog. I didn't actually make changes to the master branch of the front end application here. And so you can see we didn't fail right off the bat, right? And that will be the sign that we're probably passing that policy, right? You can see the policy is still in place. We do have a timeout set to expire in 30 minutes now. And then we won't actually see that we passed the policy until the job is done running. But since the job is running longer than job 2 was running, we know that the policy has taken effect. And so now if I go back to the lab instructions here, I'm going to go back to the workshop slides. That's basically it for this lab, right? So what did we actually accomplish, right? We created a pipeline policy that enforces a minimum 30-minute global timeout for all pipeline jobs on our master. And then, first we saw that we didn't pass that policy because the pipeline that we have in our template catalog did not have that rule in place. Once we added that to our pipeline template catalog, we rescanned our pipeline template catalog first to make sure that we were running an updated version of our job. And then once we ran it, we saw that we passed the policy that we put in place. And so, yeah, that is it for this specific lab. The next lab will be cross-team collaboration.